In the history of science, few names shine as brightly as Isaac Newton and Albert Einstein. Two men separated by centuries, yet united by a single question. What holds the universe together? Newton gave us order, precision, and clarity. Einstein gave us relativity, complexity, and a deeper truth. But when their ideas collide, who was right?
The story begins in the 17th century. Isaac Newton was a quiet, solitary figure. In 1687, he published the Principia Mathematica, a work that would transform human knowledge. In Newton's universe, the rules were simple. Every object obeyed three laws of motion. Every planet, every star, every apple falling from a tree, all were guided by the invisible hand of gravity. Newton described gravity as a force, a mysterious pull acting instantly across space. The Earth pulls on the Moon, and the Moon pulls back on the Earth. This vision explained the tides, the paths of comets, and the very dance of the planets. For over 200 years, Newton's laws seemed unshakable. His equations guided the Industrial Revolution, navigated ships across oceans, and sent cannonballs soaring through the air. The universe was a grand machine, perfectly predictable if you only knew the starting conditions. But there was a problem. Newton's theory was silent on why gravity worked. He could describe its effects, but not its cause. And as the 19th century gave way to the 20th, cracks began to appear. Enter Albert Einstein. In 1905, a young patent clerk shook the foundations of physics with his theory of special relativity, and a decade later, he unveiled something even more radical, the general theory of relativity. Einstein looked at gravity not as a force, but as geometry. Space and time, he argued, are woven together into a single fabric, space-time. Massive objects, like stars and planets, bend this fabric, and smaller objects simply follow the curves. The Earth does not orbit the Sun because of an invisible force pulling it inward. It orbits because the Sun's mass bends space-time itself, creating a cosmic racetrack. The planets are not being pulled, they are simply moving along the only paths available in a warped universe. This was a breathtaking shift. Gravity was no longer a mysterious action at a distance. It was the very shape of reality. For centuries, astronomers had noticed something strange about Mercury. Its orbit shifted slightly with each revolution, a motion Newton's equations could not fully explain. Einstein's relativity solved it perfectly. Later, his theory predicted phenomena no one had seen before. Light bending around massive objects, time running slower in stronger gravity, ripples in space-time itself, gravitational waves. In 1919, an eclipse expedition led by Arthur Eddington confirmed that starlight curved around the Sun, exactly as Einstein predicted. Overnight, Einstein became a global icon. Newton's empire of certainty had been challenged and surpassed, and yet Newton was not entirely wrong. His laws still work astonishingly well for everyday life. When engineers build bridges, launch airplanes, or calculate a baseball's trajectory, they use Newton's formulas, not Einstein's. Einstein's equations are far more complex. But in the limit of small speeds and weak gravity, they reduce neatly to Newton's simpler rules. In this sense, Newton's universe is not destroyed. It is contained within Einstein's. Newton gave us an approximation. Einstein gave us the bigger picture. One is the surface of the truth. The other is its deeper foundation. Today, both Newton and Einstein live on in science. Newton's mechanics guide countless practical tasks. Einstein's relativity powers the technology of our age. Every time you use GPS on your phone, tiny corrections from Einstein's relativity are at work. Without them, your location would drift by kilometers each day. Astronomers use relativity to understand black holes, neutron stars, and the expansion of the cosmos. But both theories also remind us of something profound. Science is never finished. Newton seemed absolute in his time until Einstein revealed more. And even now, Einstein's relativity may not be the final word. At the smallest scales of reality, the quantum world, relativity and quantum mechanics do not yet agree. Physicists today search for a grand, unifying theory, one that may one day do to Einstein what Einstein once did to Newton. So, who was right, Einstein or Newton? The answer is both. Newton captured the mechanics of the visible world. Einstein revealed the hidden structure beneath it. Together, their visions form the backbone of modern science. Newton taught us how the heavens move. Einstein taught us why. And the quest to understand the universe goes on. The apple still falls. The stars still shine. And somewhere, perhaps in the equations of tomorrow, lies the next great leap, waiting for another mind bold enough to take it.